To Unix Academy, this is Jyoti. In this video, we will discuss the services and demonstrate how to create one that exposes deployments replica pods. An abstract way to expose an application running on a set of pods as a network service. With Kubernetes, you don't need to modify your application to use an unfamiliar service discovery mechanism. Kubernetes gives pods their own IP addresses and a single DNS name for a set of pods and can load balance across them. Kubernetes pods are mortal. They are born, and when they die, they are not resurrected. If you use a deployment to run your application, it can create and destroy pods dynamically. Each pod gets its own IP address. However, in deployment, the set of pods running in one moment in time could be different from the set of pods running that application a moment later. This leads a problem if some set of pods, call them backends, provides functionality to other pods, call them front ends inside your cluster. How to do the front end find out and keep track of which IP address to connect to, so that the front end can use the back end part of the workload. In this case, it's enter services. In Kubernetes, a service is an abstraction which defines a logical set of pods and a policy by which to access them. Sometimes this pattern is called a microservice. The set of pods targeted by a service is usually determined by a selector. Services are Kubernetes objects, which means that they can be created using YAML descriptors. Here I am having an example simple service. Here I am going to create a deployment first with sample-deployment.yml is my file name. Then I will give the enter. Here I will give the descriptor for a deployment. Kind is a deployment. This deployment, it looks API version as a apps/v1 metadata section. I am giving the nginx-deployment to this deployment object. I am giving this name for this object. Then spec section, I will give the, if it is a deployment, we need to give the replicas and some number of replicas. I am giving here 3 number of replicas and then selectors, match labels, and app colon nginx. This label is match label for this selector. Then I will give the some template section in this deployment. Then I will give the metadata for this template metadata, labels, app equal to labels. Here this metadata label should be same in the selector match labels. And the spec section, I will give the container information. Number of times I have told this container information in my previous videos, and once again I will tell you. Hyphen name, I will provide this nginx name to this container. Then image, in giving this image for this deployment nginx colon 1.7.9. then ports, I will provide nginx will support 80 port. Normally that port I am giving here. Then now I am going to save this file. Then I will create this deployment kubectl create -f deployment name I will provide here. YAML script name, deployment was created. Now I am going to create a service. Now I will create the service .aml script descriptor. I am going to give the descriptor in service.aml. It will expose the deployments replica pods with a service. I'll give the descriptor in this service.aml. API version, we need to check first which object we are using here. Kind is object type. Here I am using service. This service will look API version of v1, and metadata section I am giving the name for this service my-name, and spec section I will provide cluster IP. Then selector section I will give the same which I provided in labels, template metadata labels. That label name I am providing in this selector's name in this particular service object for this particular service object. Then ports I am giving this protocol because here we won't giving the any images or any container information. Why? Because this is a service object. Here we will provide only protocols. Port protocol is TCP and port 8080, and target port is 80, which is container port. I will give the some more brief explanation about this ML script. Here we need to give type cluster IP for this service object. We need to specify this type, and later I will tell you how many types of services is available in Kubernetes cluster. Then selector section, I should say app nginx I provided here. This service that will forward traffic to any ports with the label app nginx. Then these ports specifies the port the service will listen on and which one clients will use to access it. Then here target port specifies the port that traffic will be forwarded to on the ports. If the port and the target port are the same, it's safe to omit the target port. Now I am going to save this file. Then I will create a service. kubectl create -f, then I will give service aml. Service was created. Here I created two descriptors, one for deployment and one for service. Now I am going to list those two descriptors. kubectl get deploy. This command I will provide here. On nginx -deployment is the name, ready in 3x3 and up to date is 3 and available 3 replicas. Now we will list the pods. It will also show 3 pods. Git po 3 pods are running, status was running and ready in one by one. Now kubectl get svc, you can give service full form. I am giving the now here you can observe the my service is listing with this command, that is cluster IP. I provided in this ML script. Get service, you can observe this cluster IP here. Type I provided cluster IP. Here also it's showing cluster IP. Then cluster IP a Kubernetes cluster mechanism is that cluster IP will be created. Then external IP none. Then ports I provided 80 here port number, and the target port is going to see target port is a container port. This information will provide the kubectl get svc command. We can check with one more command, kubectl get endpoints, then my service name I will provide here. You can see my service here. 3 pods are running. These 3 pods, 3 replica pods is those. We can see the 3 IP addresses for 3 pods, and port number we can see here 80. We can give the one more command with -o kubectl get pods -o void command will show the same 10.244.1.58 is the one pod IP address. Then another pod IP address is 10.244.1.59. This will show the third pod, and first pod 10.244.2.50 is the first pod. These are the commands to list those pod IP addresses, and we can see which pod are running on which node. Here IP address is providing 79. One pod is in one node. These 111 ending IP address is one node, and second node is is executing and running 2 pods here. 200. I am having only 3 node cluster this. And now I will tell you how many types of services is available in Kubernetes. In Kubernetes there are 4 sensitive service types in Kubernetes. Cluster IP, the service is exposed within the cluster using an internal IP address. The service is also accessible using the cluster DNS node port. The service is exposed externally via a port which listens on each node in the cluster. Testing purpose node port will use. And third one is load balancer. This only works if your cluster is set up to work with a cloud provider. The service is exposed through a load balancer that is created on the cloud platform. External name. This maps the service to an external address. It is used to allow resources within the cluster to access things outside the cluster through a service. This only sets up a DNS mapping. It does not proxy traffic. This is the basic information about services. We will discuss later videos in deep. We will do deep dive with services in coming videos. Subscribe my channel for further videos, and thank you.